And now the selection sort, the second of our two sorting options, which we will have to primarily set up a good situation where we can binarily search an array. Selection sort. Again, being called from a static main method. So return types and parameters. Parameters, we will be sending in an int array in this case. Int array, we'll just call it ARR. Do note that the selection sort will only work for integers. We could have named it integer selection sort. When you do your class, which will be able to sort various data types, you'll have an integer selection sort, double selection sort, and so on and so on and so on. And in terms of the return value, it will be void. Oh, we better send our array. Yeah, the return type is void. This argument gets sent and a copy is made in this parameter, but what's copied is actually the address of those numbers. So if we sort them down here, we are sorting those numbers. So this will be sorted. No need to do any return. In terms of the way this works, it is a loop within a loop. But in this case, it will be a for loop. Loop, 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 loop. Within a for loop. A loop for the passes loop. Loop, 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 loop. For loop within a for loop. I'll explain that -1 in just a moment. So this is the outer loop, the loop for the passes. We are going to be looking for the smallest number and putting it here. And then looking for the smallest number and putting it there. Looking for the smallest number, putting it there. Looking for the smallest number, putting it there. Looking for the smallest number. And when we do that final swap, both will be put into the correct position. So this outer loop is for the outer loop, 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 loop. Through each, oh yeah, no, said I'd explain this. There are only 5 passes. There are not 6 passes. And that is because in this 5th pass, both of these will be resolved. Those two are going to be swapped, which will resolve this place and this place. So the length of this array is 6. And we will actually only be outer looping 5 times. So starting at 0, it will be array length -1. 0 less than array length would still be 6 times. 0, 1, 2, 3, 4, 5 is 6 in total, but we actually only want 5, so it's that less than 1. And through each individual pass, and do note that this is showing after the first pass, after the second pass, through each individual pass, we are assuming the first of the remaining elements to be the minimum value, and then looking through the rest to see if we are correct in that assumption. And if we are not correct in that assumption, as we get to the end, we will know that there's actually another one. In this case, it would be 11, which is the least of the remaining. And at that point, we're going to swap. And you'll see that the 99 and the 11 here were swapped. And just to take that one more time, so after the first pass, that's what you would have. So we got the 11 in the correct spot, so then we assume this to be the least. And we look through the rest, and if it is, it remains. If it is not, we swap. So the 51 and 36 get swapped. So before we even get into that inner loop, then we better make ourselves an int to keep track of the element number, 0, 1, or 2, or 3. We'll call it min index. And we'll assume that to be I. So for the first time through, it's 0. We assume that to be the minimum. The second time through, it's the 1, and the 2, and the 3, and so on. So now for that inner loop, that inner for loop. We've already used I, so let's use j. It's not going to be 0. The j is going to be 1 beyond the I. Right? There's I our first time, so the j, the first thing we're going to be using in terms of looking at it is this. So j is I plus 1. As long as j is less than the array length plus right. Oh, int j. So we're then looking at this and this and this and this, and we're asking, is the value of this less than what we assumed to be the minimum? So let's ask that question. If ARR j, the value held at that, is less than the ARR min index, then we're going to adjust what we assume to be the least value. We're going to go min index is j. So as we were to go through that first outer pass, we'd assume this to be the least, and then there's our j, which is I plus 1. Is this actually less than the value held in what we assume to be the minimum? Yes. So at least temporarily, that min index is going to be 1. But actually, in this first case, as we go through, it changes a couple of times, twice, in fact. Because when we get to this one and we say, is this less than the min index? Well, the min index had changed to this one, the number 1 holding 51, and this is, 11 is less than that. So by the time we get to the end of this first pass, the min index will be 0, 1, 2, will be 3. And 3 is not, well, we haven't got there yet, so let's go on. So this takes us to here, and we know that that's our min index. So after having done that inner loop, we're going to ask the question, if min index is not equal to what we first assumed it to be, in other words, I, then we need to do a swap. And what we're going to swap is what's held at that min index I, and what's held at the new min index I. Same 3-step swap that we did for the bubble sort. We're going to, in this case, make an int temp I. This will be equal to the min index value. And finally, I'm not going to go over the swap again. We'll just do it. So min index is going to be the temp. Temp is that. That is the other one. The other one is the temp. It works. And actually, that's it. So let's just run this and prove to ourselves by making a for loop before and after. Length. Just printing out their value. And doing the same thing after the sort. And we'll put a line in between, just to be clear, and run it. So there they are unsorted, and there they are sorted. And just before I end, I'm not so sure I did the best job there at the end describing how this fits in. So just one last 30-second go over of this, that for the outer pass, we are doing a pass through, pass through, pass through, and the I, 0, 1, 2, 3, 4, is going to be used for keeping our min index, or assuming our min index as we go through. And for each time, let's just take the third pass, for example. Third pass, we'll assume that 99 is the least, but as we look in this for loop through sequentially, we find actually there's another one that's less than that. So since these two, by the time we get to here, are not the same, the assumed min index of the I, in this case 0, 1, 2, 3, is not the same as what we found our min index actually was. And so down here, we swap the values of those two.